Hello everyone, this is Vaishali. Now I am going to present about latches. In this presentation, we'll see what are latches, what are the difference between the latches and flip-flops, what are gated latches, example for gated latch, and applications of gated latches. Now we'll start with the presentation with what are latches. Latches are the digital circuits that store a single bit of information and holds its value until it is updated by a new value. They are used in the digital system as a temporary storage element to store a binary bit of information. As you can see in the first line, they store a single bit of information and holds its value until it is updated by a new value. What is meant by this statement? This statement means that latches hold some value, and when we update it with a new value, it is erased or replaced with a new value. We will not get any information about the previous value. So they are used as a temporary storage element. They are not the permanent storage element because it can be replaced or erased with a new value or updated value. So they are the temporary storage elements. And latches can be implemented by using the basic gates such as AND, OR, and NOT. They can also be implemented by using the universal gates such as NAND and NOR. Latches are the building blocks of sequential circuit. There are two types of latches, SR latch and D latch. Here we cannot see any JK latch such kind of thing. We can see only JK flip-flops, not JK latches. I'll show some example in the pictorial manner. Here is the example for simplest latch. It is by using NAND gate as you can see in the diagram. As you can see, the output of one gate is connected back to the input of the another gate. This is the main feature of the latch. This is very, very important. This is the main feature of latch. Now we will see about what are the difference between the latches and flip-flops. Major difference between the latches and flip-flops is that flip-flop is a edge trigger type of memory circuit while latches are the level trigger type of memory circuit. It means that the output of the latch changes whenever the input changes. The output is dependent on input. When input changes, the output of the latches will automatically change. On the other hand, the latches only changes its state whenever the control signal goes from low to high or high to low. In flip-flops, when clock pulse is active, then only the flip-flop will be active. If the clock pulse is not active, then the flip-flop is not active and the output remain unaffected. When it is completely based on the clock, and when it comes to latches, it's also depend upon input. Whenever the input changes, the output will also change. Then comes the common differences. We'll see about what are the common differences in between the latches and flip-flops. The common differences are latches consumes less power whereas flip-flops consumes more power. Latches are faster compared to flip-flops. Latches works based on enable signal while flip-flops works based on clock pulses. As we all know, these are the common differences in between the latches and flip-flops. Now we'll see about gated latches. Gated latches are the special type of latches. In general latches, we have two inputs, but in case of gated latches, we have three inputs. The two inputs are common. The third input is called as enable pin. Now I'll explain what is enable pin and how it is important, how it works and all. By taking an example of switch, we can compare a switch with an enable pin. First, when we think about switch, what comes to our mind? On and off of the switch, right? When we on the switch, what is meant by on the switch? The circuit, when we on the switch, the circuit is closed. Then only the current will pass into the circuit. Then only the circuit will be active, right? In the same way, when we on the enable pin, means enable pin is active. Then the circuit will be active. When switch is off, the circuit is open. Then no current will pass into the circuit. The circuit will be in inactive state, right? When we are off the enable pin, the whole circuit will be in inactive mode. I think you understood the importance of enable pin. And this enable pin can be connected to the inputs by using NAND or not. As shown in the figure, I'll show the figure. And this figure is an example for gated D latch. As you can see, we provided a D as in one input, D bar as an another input, and enable pin as an third input. These inputs are connected by using NAND gate, as you can see in the figure. And you can observe the common thing here is the output of one gate is connected back to the input of the other gate. I explained you in the previous slides this statement, right? I hope you got it now. Now we'll see the example for gated latch. Gated SR latch is an example for gated latch. You can also take D latch as an example. Gated SR latch is a special type of SR latch having three inputs, that is set, reset and enable. The enable pin must be active for set and reset of input efficiently. As you can see in the previous slide, I explained you about how much enable pin is important in the circuit. Enable pin must be active for efficient coordination in the logic circuits. I'll show the logic circuit of the SR gated latch in the slide. As you can see in the slide, this is the logic circuit for the gated SR latch, and truth table for gated SR latch, and block diagram for gated SR latch. When it comes to logic diagram, the NAND gates such as A and B are used to connect the inputs such as set and enable pin and reset. Set is represented as S, reset is represented as R, and enable pin is represented by C. The NAND gates except A and B are used to implement the basic latch, and Q is an output and Q bar is another output. The output of one gate is connected back to the input of the other gate. I think you may all know this at this. Then comes the truth table of gated SR latch. As you can see, when C is 0, whatever may be the inputs, means x and x, we represent x means it may be 1 or it may also be 0. It may, whenever it does not depend upon inputs, it only depends upon enable pin. When 0, will not get any change in output, we'll get the previous output. And when the C is 1, we'll get different outputs. We'll see this different outputs in next slides. Then comes the block diagram. We can see yes, we can in logic diagram we saw by using NAND gates. Here we saw only the pictorial representation of gated SR latch. We can represent Q and we can represent Q bar, or by using a bubble. Bubble represents the negation, so we can use bubble also there. Now it's time to see the detailed explanation about truth table. I already shown you the truth table in the previous slide. You can take the screenshot of that truth table and compare it with here. When the enable pin is 0, means the whole circuit is in inactive mode. The whole circuit is inactive means the output will not get any output. The output will be same as that of previous, because when we provide, regardless of inputs, because when we provide input but the enable pin is inactive, then how can we get output, right? The whole circuit is in active mode. So when we change the inputs also, we will not get any output. So to get the output, the enable pin must be active. So we'll now see the cases where the enable pin is active, and we'll give different outputs like 0, 0, 0, 1, 1, 0 and 1, 1. When enable pin is 1 and the inputs are 0, 0, S is also 0, R is also 0. In this case, output will not change. It will remain same as that of the previous case. And when S is 0 and R is 1, the output will be Q is equals to 0 and R is 1. This means it resets the input. And when S is 1 and R is 0, the outputs are Q is equals to 1 and Q bar is 0. This means it sets the input. And when S and R both are 1, this means in both inputs are active in this case. In this SR gated latch will not get any output. It is undetermined. This state we call it as forbidden state, and this is overcome by JK flip-flops in higher order. We'll see it in the next coming videos. Our classmates will place the videos. You can refer that. And this is all about the truth table of the gated SR latch.